You ever find yourself needing to fence a yard, or maybe frame a picture, or even just figure out the distance around a running track? At the end of the day, you're really asking one simple question. How do you measure a boundary?
So in this explainer, that's exactly what we're going to do. We're building your essential toolkit for calculating perimeter. We'll take that big question and turn it into a set of simple, powerful tools you can use for pretty much any shape that comes your way.
Okay, so what is perimeter, really? Put simply, it's the total distance around the outside of a 2D shape. I love this way of thinking about it. Imagine you're a tiny ant walking along the very edge of a shape. The perimeter is just the total distance you'd walk to get right back to where you started.
So here's our game plan. We'll kick things off with uniform shapes, then we'll level up to variable ones, we'll tackle the special case of circles, and finally, we'll put it all together in your complete perimeter toolkit. Sound it? Let's dive in.
All right, first up, the uniform shapes. And the absolute beauty of these is that you only need one single measurement to figure out the entire boundary. That's it.
We're talking about the classics here, right? Shapes where every single side is the exact same length, like squares and equilateral triangles. They're the perfect place to start because they make understanding how this all works a piece of cake.
Let's take a square. It's so simple, it's kind of elegant. You've got 4 equal sides, right? So the perimeter, which we'll call P, is just 4 times the length of one of those sides, which we call S.
Okay, now check this out, because this is a great little trick, especially with fractions. Let's say one side is 8 3/4 inches. First, we turn that into what's called an improper fraction, so 35/4. Then you just multiply by 4. And look what happens. The 4's on the top and bottom just cancel each other out. And boom, you're left with a nice, clean 35 inches. So easy, right?
And guess what? The exact same logic works for an equilateral triangle. I mean, the name kind of gives it away, right? Equilateral. It has 3 equal sides. So the formula is almost identical, just with a 3 instead of a 4. Perimeter equals 3 times the side length S.
And we're going to use that same little trick here. A side length of 9 1/3 feet becomes 28/3. Multiply that by 3, the 3's cancel out, and you're left with a perfect 28 feet. See? Once you get this pattern down, you can solve these in a heartbeat.
Okay, you ready to level up? Let's move on. Let's look at variable shapes, where things get a little more interesting, because not all sides are created equal. Now, we're getting into figures like rectangles and all sorts of other triangles. For these, you're going to need to know more than just one side. Our toolkit is officially expanding.
Take the good old rectangle. You know how it has 2 equal long sides and 2 equal shorter sides? We call them the base, B, and the height, H. So this formula is really just a super fast way of adding up all 4 sides, 2 bases plus 2 heights.
Here's another great strategy for you. Instead of wrestling with fractions, sometimes it's way easier to just convert them to decimals. So 5½ becomes 5.5, 5 1/4 becomes 5.25. Then we just plug them into the formula. 2 times 5.5 plus 2 times 5.25. That gives us 11 plus 10.5 for a grand total of 21.5 inches. Nice!
Triangles could be a mixed bag too. For a general triangle where all 3 sides are different lengths, you just add them all up. A plus B plus C. Super straightforward. But for an isosceles triangle, that's the one with 2 equal sides, you can use a little shortcut. 2 times the equal side A plus that one different base B.
Okay, watch out for this one. This is a super common trap. Mixed units. If you've got sides in feet times inches, you can't just add the numbers. The absolute key here is to get everything into the same unit first. So we'll change those 18 inches into 1.5 feet. Then, and only then, can we add everything up. 9 plus 8 plus 1.5 equals 18.5 feet.
All right, we have totally mastered straight lines. But what happens when there are no straight lines? What about curves? This brings us to the special case of going around in circles.
You know, the perimeter of a circle is so special it gets its very own name, circumference. And to calculate it, we need a little help from a very famous, kind of magical number that literally goes on forever. You guessed it, pi.
Now you'll see 2 formulas for circumference, but don't let that fool you. They're really just 2 sides of the same coin. It all depends on what piece of information you have. If you know the diameter, d, that's the distance all the way across the circle, you use c equals pi times d.
If you only know the radius, r, which is just halfway across, you use c equals 2 times pi times r. And that makes perfect sense, right? Because the diameter is just 2 radiuses.
Let's see it in action. If our diameter is 3.5 centimeters, we can turn that into 7 over 2. And for pi, a really handy fraction to use is 22 over 7. When we multiply them, look at that. The 7's on top and bottom cancel out, and 22 divided by 2 gives us a clean 11 centimeters. How cool is that?
Wow, we've covered a lot of ground. So now let's pull all these tools together and build our complete reference guide.
And there you have it, your complete perimeter toolkit. This table is your cheat sheet. It's got everything we talked about, from the simple p equals 4s for a square, all the way to the various triangle formulas, and of course, circumference for a circle. This is your go-to guide for measuring the boundary of pretty much any basic shape you'll ever run into.
So, you've totally mastered the edge, the boundary, the perimeter, but that kind of leads to a new question, doesn't it? What about all that space inside that boundary? Well, that's a story for another time.